After studying this module, you shall be able to know ancient tools and measurements, units of measurements, forensic metrology. One of the most important skill which early human being developed was the ability to measure. According to one belief, people learned to measure much before they learned to write. And it was the capability to measure that people learned to count. During the Peking and Neanderthal period, people carved their tools out of the natural materials. Some very interesting methods were used to do the measurements. For example, various body parts such as fingers, hands, arms, legs were used to measure the distance. Weight was measured with the help of certain containers which an individual or animal could pull. Gradually, the methods of measurements and tools became more and more sophisticated and were converted into measuring sticks. The evolution of the units of different measurements, which started from the primitive unorganized way to well established and very well organized way. Earlier these units used to vary from one area to other, but now it is uniform throughout the world.
Initially, some very interesting methods were used to do the measurements. Example, various body parts such as fingers, hands, arms, legs were helped to measure distance. Weights was measured with the help of certain containers which a individual or animal could pull. Since human being has 10 fingers that can be used to count tens, diverse procedures were framed to connect dissimilar units with different body parts. Time was measured through the phases of the sun, moon, and other heavenly bodies. When it was required to match the capabilities of containers like gouts or clay or metallic vessels. They were full with plant seed and were then calculated to measure the volumes. Some of the familiar early units of measurement areas are: first is inch, the width of the thumb; second is digit, the width of the middle finger, which is about 3/4 inch. Next is palm, the width of fourth fingers, which is about 3 inches. Next is span. It is the distance covered by spread hand, which is about 9 inches. Next is foot, the length of the foot, later expressed as the length of 36 barrel cones taken from the middle of the ear, which is about 12 inches. Next is cubit. It is the distance from the elbow to the tip of the middle finger, which is about 18 inches. Next is yard. It is the distance from the middle of the body to the fingertips of the outstretched arm, which is about 36 inches. Next is fathom. It is distance spanned by outstretched arms, which is about 72 inches. These units had a grave limitation, that is, related with uncertainty. about the body size, which vary among individuals. Such variations resulted in difficulty to establish standards. When individuals worked in a group, mostly the leader of the group would use his body parts as the parameters. Any measurement would be matched to the standard of the size of his body parts. Every civilization kept working in order to set up various systems of weights and measures. As the international interchange of goods and communication of ideas was limited in those times. It is not astonishing that diverse systems were developed for the same resolution and became recognized in diverse parts of the world, even in diverse parts of the same country. Now let us learn about units of measurement, which is a English system. The measurement scheme generally used in the United States even today is almost the similar as that of was brought to them by the colonists of England. These procedures has their roots in assorted cultures like Babylonian, Roman, Egyptian, Anglo-Saxon, and Norman French. The ancient digit, palm, span, and cubic units of length slowly lost their preference to other set of length units such as inch, foot, and yard. The yard is used as a measure of length that could be marked back to initial Saxon kings. The word yard came from Saxon word grid, which means the boundary of individual's waist. Those people used to wear a girdle around their waist, which could be easily detached and used as a appropriate measuring tool. Other units which American commonly used are the gallon, presently has one description in the Imperial Organization and two definitions, that is liquid and dry, in the US customary scheme. A gallon is a measure of volume mostly used in the United States and many other English communicating countries. Other countries use liters, the metric unit of measures for volume. Various types of gallons available, that is US liquid, US dry, and UK, and value in terms of liters is shown in the given table. The empirical gallon or UK gallon, now defined as exactly 4.5461 liters, that is used in some Commonwealth countries and was originally grounded on the volume of 10 pounds, approximately 4.54 kg of water at 62 Fahrenheit or 17 Celsius. The imperial liquid ounce is defined as 1 by 160 of an imperial gallon. There were 4 quarts in a gallon, 2 pints in a quart, and 20 fluid ounce in an imperial pint. Next is US liquid gallon. The US liquid gallon, that is equivalent to exactly 3.78541178 liters, is officially well defined. as 231 cubic inches. A US fluid gallon of water weighs around 8.34 pounds or 3.78 kilograms at 62 degrees Fahrenheit and 17 degrees Celsius, forming it about 16.6% lighter than the imperial gallon. Next is the US dry gallon. This gallon is equivalent to accurately 268.8025 cubic inches or 4.40488377086 liters. The US dry gallon is not used in commerce and is not recorded in the applicable statute, which excites from dry quart to the peak. Intricate unit of volume in the metric method, liters of water weigh up 1 kilogram. Scientific community of most of the countries other than US uses common metric system. Next is forensic metrology. Forensic science, being multidisciplinary in nature, has different branches in forensic science laboratories. One of the important division of forensic science laboratory, the service of which are used by almost all branches, is named forensic metrology, which deals with measurements. The word metrology comes from Greek, that is, metron, means measure. It means, amongst others, speech, oration, discourse, quote, study, calculation, and reason. In ancient Greek, the term metrology means theory of ratios. The application of forensic metrology may include the reconstruction of an accident case or an expert measuring the length of skid marks and yaw marks to determine the speed of vehicle. Measuring the blood alcohol concentration has also long been thoughtful subject with drunken driving prosecutions. The quantity of measured materials, both in relation of their total weights and purity, or determining the length of firearm barrels, are other substance which are enclosed by this branch. Metrologists, however, accept that there is an inevitable and inherent component of uncertainty in every measurement made either at the scene of crime or in the laboratory. A number of measurements and tests are conducted in any forensic science laboratory in order to analyze the evidence in both civil and criminal cases. Forensic science being interdisciplinary in nature, the analysis ranges widely from DNA sequencing to electron microscopy to the manual matching of footprints, fingerprints, lip prints, and tool marks, etc. One problem which can hammer a forensic analysis is samples which are degraded, incomplete, or presented only in very small amount. It is thus vital for the forensic scientist to procure the complete array of measurement tools required to ensure best results. The scientists trust their exertions to measure uncertainties, which means that even for the most cautiously performed measurements, the value can never be exactly precise. It is only an estimated value. Thus, measuring uncertainty and error rates plays a vital role in the forensic examination. Now, let us learn about International Organization for Standardization. Recently, plenty of devotion has been given to forensic metrology and metrological traceability as a result of international efforts to accredit forensic science laboratories according to the requirements of International Organization for Standardization 17025. International Organization for Standardization, also known as ISO, established on 23rd February 1947 in an international standard setting body comprising of the representatives from various standard organizations of different nations. This organization supports worldwide proprietary, industrial, and commercial standards. It has its headquarters in Geneva, Switzerland, and as of 2013, it works in 164 countries. The three official languages of ISO are English, French, and Russian, as its name will have abbreviated differently in different languages. IOS in English, OIN in French, etc. The association accepted as its abbreviated name ISO, which is emitted from Greek word ISOS meaning equal. Both the name ISO and the logo are recorded logos and their use is limited. Now, let us learn about International SI system of units. During 1866 in United States, it turned out to be legal all over the United States of America to hire the weights and measures of the metric method in all contracts, dealing, or court proceedings. However, in 1875, an international contract called as the Meter Pact set up well known metric criteria for length and mass, and recognized long lasting mechanisms to mention and accept further modification in the metric system. This agreement, commonly called as the Treaty of the Meter in the United States, was engaged by 17 countries comprising the United States. Number of nations increased to 35 in 1900, including the major nations of continental Europe and most of South America had officially accepted the metric system. The General Conference on Weights and Measures, that is, in 1960, adopted an extensive revision along with simplification of the system. Seven base units, the meter, that is to measure length, the kilometer to measure mass, the second to measure time, the ampere to measure electric current, the Kelvin to measure thermodynamic temperature, the mole to measure amount of substance, and candela to measure luminescence intensity were established. The name System International Units with the international abbreviation SI was adopted for this modern metric system in 1988. Amendments to the Act designated the metric system as the preferred system of weights and measures for United States trade and commerce. After this amendment, the measurement science continues to develop more precise and easily reproducible ways to define the measurement units. The General Conference meets periodically to ratify improvement in SI system in years 1964, 1967 to 1968, 1971, 1975, 1979, 1983, 1991, and 1995. Presently, all the forensic measurements in the laboratory investigations are supported by reference standards, which are traceable to the International System of Units maintained by the International Bureau of Weights and Measures. Example of instruments and equipments used in forensic metrology include breath analyzer, balances and scales, rulers, calipers, gas chromatographers, and centrifuges, etc. Units can be divided into two different types: the base units and derived unit. First is the base units. Quantities measured: length, mass, time. Length is measured in terms of meter, mass, kilogram, and time, second. Units related to thermodynamic: temperature, amount of substance, electric current, luminance intensity, that is Kelvin, mole, ampere, and candela. The five base units which are useful in general chemistry are defined as follows. First is meter and centimeter. A meter was originally measured to be 1/10 millionth of the distance from the North Pole to the equator along the meridian running near Dunkirk, Paris, and Barcelona. It was redefined in 1971 as the length of path traveled by light in a vacuum during the time interval of 1 by 299,792,458 second. A centimeter, a smaller unit of length, is equal to 1/3 of a meter. Next is the kilogram and the gram. A kilogram is the mass of a particular cylinder made up of platinum iridium alloy. It is known as International Prototype Kilogram. It is kept at the International Bureau of Weights and Measures in Sèvres, France. It was derived from the mass of a cubic decimeter of water. 1 gram equals 1,000th of a kilogram. Next is the second. It was originally defined as 1 by 86 400th of a mean solar day. It was redefined in 1967 as the duration of 9,192,631,770 periods of the radiation, which corresponds to the transaction between two hyperfine levels of the fundamental state of a cesium, that is 133 atom. Next is the Kelvin. It is 1 by 273.16 of the temperature interval between absolute zero and the triple point of the water, that is, the temperature at which ice, liquid water, and water vapor in the equilibrium. The Celsius scale is derived from the Kelvin scale. An interval of 1 Kelvin is equal to 1 degree Celsius. Next is the mole. It is the amount of substance which contains as many entities as there are atoms in exactly 0.012 kg of carbon 12. This number is known as Avogadro's number, which has a value of 6.0220943 into 1023 per mole, that is 6.3 into 1017, determined by US National Bureau of Standards in 1974. Now let us learn about measuring the base units. First is the measuring length. To measure length as a distance and use the metric ruler and the metric tape to measure the length, width, and height of the object in question. Converting inches into the centimeters and feet into meters is a regular practice in mathematics and science. The given conversions which are commonly used are shown. Technically, one conversion is required, but sometimes it is easier to use the one which is closer to the values of our requirement. Now let us see English system of measurements to measure distance. 12 lines equals to 1 inch. 12 inches equals to 1 foot. 3 feet is equal to 1 yard. 1760 yards is equal to 1 mile. 36 inches is equal to 1 yard. 440 yards equal to quarter mile. 880 yards is equal to half mile. 100 links is equal to 1 chain. 10 chains is equal to 1 furlong. 8 furlongs is equal to 1 mile. 4 inches is equal to 1 hand. 22 yards is equal to 1 chin. 5.5 yards is equal to 1 rod, pole or bridge. 4 poles is equal to 1 chain, and 40 poles are equal to 1 furlong. Instead of having a large number of units of different sizes, such as inches, feet, years, fathoms, furlongs, and miles, etc., in the English system, it was decided to use prefixes which would multiply the base units by multiplies of tenses for larger measurements and decimal fractions for smaller measurements. According to the metric system, the basis of length units for the metric system is the meter. This name was derived from the Greek word metron, meaning a measure. The physical standard representing the meter was to be constructed so that it would equal to the 1/10 millionth of the distance from the North Pole to the equator along the meridian running near Duck Creek in France. A meter is almost the same length as 1 yard. The metric system is based on units of 10, which means 1 centimeter is equal to 10 millimeters, 1 meter is equal to 100 centimeters, 1 kilometer is equal to, which is equal to 1000 meters, which is further equal to 100,000 meters, and similarly, the surface area of a cube can be calculated by adding together the surface area, that is, length into width. of all six sides. The volume of a cube is equal to length, width, and height. Now let us see popular conversions used to measure distance in meters. 1 inch is equal to 2.54 centimeters. 1 foot is equal to 30.48 centimeters. 1 yard is equal to 0.91 meters. 1 mile is equal to 1.6 kilometers. 1 millimeter is equal to 0.404 inches. 1 centimeter is equal to 0.39 inches. 1 meter is equal to 3.28 feet, and 1 kilometer is equal to 0.62 miles.
Summary. Some very interesting methods were used to do measurements. For example, various body parts were used to measure the distance. These units have a grave limitations that is related with the uncertainty about the body size, which vary from one person to another. The application of forensic metrology may include the reconstruction of accident case or an expert measuring the length of the skid marks and the yaw marks to determine the speed of a vehicle. Measuring the blood alcohol concentration has also been a serious issue with drunken driving prosecution. The problems which can hamper forensic analysis is samples which are degraded, incomplete, presented only in a very small amount. All the forensic measurements in the laboratory investigations are supported by reference standard which are traceable to international system of SI maintained by International Bureau of Weight and Measures.